Good morning, in as many languages as you speak here, and welcome back to day 2. I'm Craig Cornelius. I'm going to talk about something that's less exciting than languages, but a topic that is about Unicode and conformance testing. Right now, ICU and CLDR data are available on not just ICU for C and ICU for J, but a number of other platforms. For example, NodeJS, which is available in many browsers as a built-in form of JavaScript, has Unicode data in it. ICU for X, you're going to be able to hear about today, which is another platform kind of built from scratch, but again, using CLDR and ICU information. Dart Web and many other platforms are starting to use the key data and algorithms of the Unicode system in their products. And if everything works right, and that's a big if, everything should use the same CLDR data. Every one of these should process it the same way. Now, why is this important? In a Google system, for example, such as Google Search or Gmail or YouTube or any other product that you may build or we may build, there is a backend typically that is preparing an initial web page, and there may be something happening in the web browser, maybe driven by JavaScript or Node.js. If you get information from the backend and put it on the screen, and then something is updated from the client side, in other words, your laptop or phone, those dates and times should not switch in the ways they are formatted between something coming from the back end and from the front end. They should be consistent. But as of a year and a half ago, nobody could prove that. The big question is, how do we know? What does each of these different platforms, which purports to be the same stuff, actually work? What do they actually implement? Do they all conform with the same data, the same specifications? What is the gold standard for what they're producing? Which tests that are in the specifications will pass? Are there some that will fail? Do they fail in the same way? Are there any test cases that produce great things on ICU for J, but cause a runtime error on a platform that might be running on your phone? And are there features that in some of these are not yet supported, even though they might be in the big libraries? And then another question is, if I do want to make these completely consistent, how can I be sure that I'm calling the functions correctly? Node.js calls are very different than ICU for X calls. Do I have an example of how these are going to be working? Now, ICU does have many test specifications. In the GitHub repository here, which is under ICU for C, source, test, and test data, there are more than 60 test data sets. And they've been built over many years of the Unicode and ICU process. Several examples are the collation tests. There are several different number formatting tests, likely subtags, date and time cases, and so on. And what these are specifications of saying, given these parameters, like the locale, like the type of number formatting you want, like the number of significant digits you want, like the form of date and time, given those parameters, this is what you should get. So it's a specification saying this stuff in, and you should get this out. And each of those has the required results. But unfortunately, these have been developed by many different people over time. They have many different formats. They're not all easy to import into the tests for Node.js, for example. What we've done is built something called, we call conformance testing. I also call it data-driven testing. And even though it isn't correct these days to use DDT in the environment, DDT is really good for finding and stomping out bugs. So this is a younger audience. Don't remember the 1960s and 70s, maybe, about the chemistry. What we've done is decided to build a data generator that will take all these specification files and generate individual tests from that data and make each one a separately executable test. We built a big file of these in a format called JSON, which is very portable among different platforms. Then we've written a test driver, which will automatically run the tests that we've configured on all these different things. So for collation testing and number format testing and so on, it will run hundreds or thousands of tests on each of these. And the test driver can execute these in Node, ICU for X, web or dark web, and other platforms. And this can be configured with a small configuration file. Then we take the expected output from each one of these tests, which has not been given to the test driver. And the verifier says, okay, these are the results from the tests being run. These are the expected results. It matches them. And it checks which ones have actually passed, which ones have failed. It also records the ones that might have given a crash, a test failure. And if the test says, I don't know how to run this test, it will record information that it's unsupported. And finally, we have a report system here. And this is all under GitHub. And if you would like, you may go to this GitHub site where ICU Conformance is currently stored. This is a system diagram. And as you can see, it has all these components that I just mentioned. The first part is the test data generator. These the major modules are all written in Python 3. So you could download them onto almost any computer yourself. And that's a nice thing about open source software. You could bring this whole thing down onto your own computer and run all these conformance tests yourself. And because it is meant to be open and extensible, you could start building your own tests. The test executions place is designed so that multiple tests can be plugged in very easily. And noted that I've got several dots in there so that you could add your own system if you need to. The test verifier is simply another Python program that takes the output of the test generator with the expected results, takes the output of the test execution and compares them. And then finally, we build some web pages with some JavaScript in there that makes it possible. There's also a brief thing down at the bottom right, which says JSON schema. All of the files that are JSON also have their own specifications about what the form can be, what fields are required, what fields are optional, and what they mean in there. That's a small part of this. This testing is actually more complicated than I expected when I first got into this. It has 3 dimensions plus a couple more. First of all, each specification might indicate actually thousands or tens of thousands or hundreds of thousands of tests. For example, the collation tests amount to about 400,000 tests, and they are simply comparisons of this string versus this string. Is this string less than this string according to the platform you're running? If so, the test passes. Some of them have a few more parameters, but you can imagine that there are a lot of possible comparisons for this, and these tests are very extensively built and run, and they should be all running in your computer as well as the ICU for C and ICU for J implementations. So that's many, many individual tests. There are different kinds of tests. We have several of them implemented now. Collation, checking for language names so that they are consistent. Likely subtags is a way of saying, what is your locale? And can it be expanded or reduced to something that is more commonly understood by your program? And number formatting, which is a big one. We have many more that we'd like to add. The data also needs to be done on multiple ICU versions. We are actually going back to ICU 70, ICU 69 several years ago. Because the test data changes, the test specifications also change between different versions of ICU and CLDR. Then we have multiple test platforms, and I've mentioned several of them, and we'd like to do more. And we can also support multiple versions. So ICU for X, for example, we started testing in ICU for X 1.1. We've advanced to 1.2, and now we're on a 1.3 version. But we test multiple versions of Node. This is especially important because not everybody's browser has the absolute latest version of Node in it. So we have to check with multiple generations of Node. And finally, because each one may have hundreds or even thousands of tests, we have to build this in such a way that it can run in a reasonable amount of time to give good coverage. Here's some sample test data that we built. The original test has very, very compact specifications that says do all these combinations of parameters with all of these combinations of locales, and it turns out that it expands to about 7,000 different tests. So in a JSON file, and this one is for number format, and notice I have the word test in there, it has a test type explicitly, and then it has an array of tests. And each test has a label, which is a unique number within that test that allows us to match it up with the expected results. It has a locale indicating that, for example, this one is going to be done for Mexican Spanish or Bengali numbers or Chinese numbers. We could do it for almost any locale. It has an input. This number is input as a string, and that is going to be formatted according to a specification. And this particular test says, I want to do a compact one. Compact means something like instead of 92,000, I would like to 92, or instead of 91,827 something, I want to do 92K in English, for example. Compact display, I want a short version of that compact. Unit display, it's narrow, and number of significant digits can be specified, along with a lot of other options that are supported by most of these platforms. So this is an example of one of the 7,000 plus tests in number formatting. A separate file is created with the expected result of this, and it's very simple. In this case, the same label, 730, has a verify value, and this is the equivalent of 92,000, 92K in Spanish, with a non-breaking space in between. And that's in the Unicode format, U00A0, because that's easier to understand than just a blank, which looks like the normal ASCII space. So again, this file has about 7,000 entries, and this is an example of number formatting. We have similar files for collation, likely subtags, language names, and the tests that we continue to add. One of the tricks with this is that we have 4 or 5 dimensions of data. We have hundreds of thousands of tests to run. And how will I even present this to someone so that a person can understand what the heck's coming out of this? There are so many possibilities here. So we thought quite a bit about how we can represent this. Again, with the dimensions here, how do we make it possible for people to understand and access it? Well, this is pieces of our summary page. And again, you can go to the summary page here and see this latest report. Along the top, I have 3 of the platforms, Dart, NodeJS, and ICU. And then I have a row for each of the different test types. So the top row is collation. The next row I'm showing here is number formatting. And there are 2 more rows in this rather large display for the other kinds of tests. And within each one of these, you can see, for example, in Node.js, I have Node 14, and it is running with ICU 69 data. Node 18 is running with ICU 72 data, and so on. So these are the multiple versions of data and multiple versions of the platforms. So with this, I have a visual display of what's going on. What does this mean? The green says, as you might expect, tests are passing. The red means, oops, the test is failing. It gives a result, but it is not what is expected. And in a couple places, you can see, like the yellow indicates there was some sort of test error. It said, I can't compute that, or, oh, the locale you gave me isn't understood. And also in many cases, especially in number formatting here, you can see that there are a lot of bars which are gray. A gray bar means I don't yet have information about that, or I don't yet process that kind of data in this particular system. Now, because we have written a program which says, take the test data as a JSON specification and write a little program that calls Node.js or calls the ICU or calls the Dart web function, we may have made some mistakes in those function calls. So some of these errors aren't really a problem with the underlying platform. They may be just that we have not called them correctly within my code, the code that our team has put together. So what we'd like to do is eventually get rid of all those red bars, because they really shouldn't happen if a platform is correctly implementing things. But we want to take all those red bars and turn them either into green bars, which means we call the system correctly, or turn them into gray bars, which means, yes, they should work, but we don't yet have that information in this particular platform. And of course, we want to get rid of the yellow bars, which say, it isn't working. There is test detail that you can get for each one of these. So this is a verification report on number formatting in Node. And note that there's a nice long green passing bar, a tiny little failing bar with only a few errors there. And we can open up the section on passing and get all the information for each of the test labels. There's an expected value, there's a resulting value, and there's all the input data, which was all the details going into the test. And then at the top is all the test details, which I will, and you'll be happy that I will not read all this to you, but this gives all the information about the particular data, the particular version of the application that was running, and exactly when it was done. And again, you can click on these links and find it. But especially when a test fails, you may have heard the term, spare me the details. I don't want to know all the information. Well, we want exactly the opposite. If there is a problem, we don't want to be spared the details. We have to dig into those details. But because hundreds of thousands of tests have been run, I want to first of all isolate those that have failed, and then I want to start looking at the details of those. So we have a scroll bar at the top, or a bar at the top, which lets us select subsets of these, so I don't have to see hundreds of thousands of these at one time. I can scroll through them. I see the expected value. The result is something different. And the label lets me know exactly which one it is. And then the input data is given there in great gory detail. The sources of failure I've indicated might be that the test didn't generate the test data properly. We've run into some of those cases, that I didn't call a function properly, or that I failed to say this is not supported. But sometimes we find out that the platform itself has a problem. I want to show you one example in a moment. There are 4 kinds of test results, as I've indicated. I put them with colors there so it's easy for me to see what's going on, but the goal is to move them all from failing to either unsupported or passing. In other words, we want to make sure we're testing each of these platforms correctly. There was something odd when we ran number formatting in the ICU for X. We couldn't figure out why all the ESMX locale number formats were coming out wrong. At least all the ones that had decimal points and commas separating it. And so expected is 1,827.364. Why is that? Well, it's Spanish. Why shouldn't it do like Spanish in Spain? Well, Spanish in Mexico and Spanish in Spain are different. Why? The Mexicans do the same thing as the US does with the number formatting, probably because we do so much trade and communications there. But it was actually putting this out with a different format with a comma where I would expect a decimal point to be. And all this other information, we looked at it and we said, there's no good reason why we should be getting the result actual versus the expected result. What's going on? So literally 2 weeks ago, Shane and I sat down with this and all the other failing tests and said, what the heck's going on? We looked at it. The number format has about 7,000 test cases. The ESMX ones were failing. We took a good look, and I'm not the ICU for X programmer, but Shane is. And he said, let me figure out what's going on. He looked at the inheritance. ESMX is a subset of Spanish in most cases, but when something inherits, it means you don't duplicate all the things from the base locale in the more detailed locale. You inherit information. But ESMX should not inherit from ES as in Europe. But there was a mistake in the ICU for X implementation of this complicated process of inheritance. Inheritance needs to consider not only what's the name of the base language, but does it really inherit certain properties from that base language, or does it inherit from another one? This should have been inheriting information from ES 419, which is Latin American Spanish rather than European Spanish. And Shane found the bug. We went through a couple cycles of trying to fix the bug, and finally Shane said, try it with this one. What happened was that hundreds of errors in ESMX boiled down to almost no errors in the ICU for X implementation of number formatting. And it turns out that this particular fix applies not only to my little program for conformance testing, but it will fix anybody who's using ICU for X for number formatting and maybe for other things as well, because the inheritance is something used in all of the locales and all the kinds of data. So we went from the chart on the left with a bunch of red bars to the chart on the right with almost no red at all. Now, if you expand that, there are a few tests failing that we still haven't explained. But the point is that it had a big win, and it found something that wouldn't have been found otherwise, except by somebody complaining when this actually gets into a product. We're happy to find it now, and now this is conformant with all the other implementations of this number formatting for this locale. And it may have fixed other locales where the inheritance wasn't obvious in our testing. Now, the other testing briefly is collation, which is basically saying, how do these two strings sort? Has over 400,000 test cases, and some of them include particular locales because sorting does vary upon the language and sometimes the region where you're sorting. It shows broad conformance in almost all the platforms, but there's some test cases that we still have to figure out why they aren't working. For language names, we don't have a specification in ICU test data, but we built the results, the language names that we expected. For example, if I am going in English, I expect to see the language names of French, German, and Spanish. But if I'm in French, I expect to see Allemand, and I expect to see Français, and I expect to see Espagnol. And in Deutsch, German, I expect to see Frankreich, or Französisch, and English, and Spanish. So the language names in other languages is really important. It turns out a couple 100,000 tests are mostly working in all of these platforms, but we have some things to figure out. We have to figure out our test data properly, and we have to make sure that all the implementations are correct. Likely subtags are also used, a much smaller set of test cases, and I'm not going to go into the details here, but many of these are still unsupported, especially when the language, the locale is specified with both the language code, the region, and the script. There's a lot that's not yet supported in all the platforms. Now, the status is that we are supporting data from ICU 69 up to ICU 74, and we have these three platforms. We have 4 different kinds of tests, and the automated testing that is done whenever we introduce this or whenever we make a submission into the GitHub system is that all of the GitHub actions are run automatically. It generates all the data because we might have changed our test generator. It generates all the test results from all the different platforms, all the different language versions, or all the different platform versions, and outputs these as JSON files. The verification runs automatically, and the new results are generated, creating these data displays. And these data displays, you can go to the website and you can explore them in great detail. You can look at every single test that's passing, failing, or unsupported and find out as much as can be found out. Now, if you'd like to add your platform to this, and we'd encourage you to if you have a platform, simply, first of all, make sure that your platform will indeed run within the GitHub system, and that includes almost everything that runs on a modern computer. And then add a program, which is a test executor, a main program which will accept a JSON line of text, or a JSON data structure, which includes the test type and the specifications for that particular test, and parse that information, call the right function, take the result, package it as JSON, and send it back to the test driver, which will happily put it into a test results file for you. And then the verifier will take that data when all the tests are run and add this to the output. All one really has to do to get this going for your particular platform is add it to a configuration file, which will set up the environment for that particular execution and tell where it is, and boom, it'll work. Now, of course, nothing's ever as easy as that. Whenever anybody says, all you have to do is, you should definitely ask more questions. But this has been proven to work pretty well. Our colleague Moritz Zimmermann in Germany added the Dart web quite successfully without even talking to us directly, just a few emails, and he was able to add that whole column of test platforms. Now, if you'd like to participate, we could use your help. We have many more test types that we don't actually run yet. We'd love to run through more of those 60+ test specifications. And that means adding a schema for the test data and adding something to the test executor that will actually do the right kinds of calls. This won't be possible for every platform yet because not every platform implements all of the ICU functions, formatting data of different flavors. And you can help us look at these and say, this is a test failure. What's really going on here? You can actually take a look at that and try to figure out what's going on because all the code for running the tests is on this website as well. And you can help us make it easier for people to work with. What we're working on now, adding more test types, and there should be a space in that. We'd love to do lots more. We want to resolve all these test failures, of course. We would like to add ICU4J and ICU4C as new platforms into this, not because we don't believe that they don't work, but because we want to make sure that we can directly compare. One of the things I want to do is be able to say, take this test result and this test result and actually compare them and see which tests fail in common, which tests work in common, what differences in the test outputs are there in more detail. So there's a lot more we could be doing with this. These are the collaborators that have been working on this so far. We happen to all be or have been Google people, but there's no reason why you can't participate. And that's all until you get started. And there's where you can go. How'd I do on time?
Well, we have time for a few questions. Thank you, Craig. Let's give Craig a round of applause.
Any questions, comments? This isn't nearly as exciting as real language stuff.
I think it's exciting.
Text.
Good talk, Greg. I missed the first couple of minutes. Maybe you already addressed this. What's the turnaround time for running all of the tests? And is there maybe a smoke test version where you'd like to get quick results, and maybe running all of the tests is not as productive as for some kinds of work as just pulling out? Is it basically okay?
What a good question. That's one of the slides that I took out to try to fit in the right time. The time to actually process everything, the whole kit and caboodle, as they say, which is done in the GitHub Actions, is about 20-25 minutes on my Linux box. And that includes generating hundreds of thousands of tests and running all the tests. That in GitHub isn't terrible. One just waits for the results. But when I'm doing actual testing myself, I set up the test generator and the test execution so I can say run limit. I can limit it to 100 test cases to be generated for each of the types of tests, as opposed to hundreds of thousands, and it runs much faster, lets me get feedback. So each of these components has parameters that can be used to limit that.
And when you're checking in a change, you're submitting code, you run all of these, or you run a more limited version? Because you know, doing a check-in and then waiting 25 minutes for results is maybe an obstacle to development for some situations.
Good question again. For the GitHub Actions for the submit, there's a quick test which runs with just a small subset of this, and if that fails, then your submission isn't going to work. So you get pretty fast feedback if your update is not going to work quickly, and I use that myself. So I often run this locally before I submit anything. I often get hung up when I forget to do things like running Rust. The Rust lint or the Rust formatting test. That is one of those tests that will frequently fail. I say, I got to fix that. But I can fix my GitHub Actions to run these things automatically before I actually try submitting. Does that answer your question?
Yeah, very good.
Yes, I got tired of waiting for hundreds of thousands of tests to run myself. Any other questions?
I have a question / comment. I'll do that first.
Sure.
Then give it to them, and each can do next. I'm just going to scroll back to this slide here because I just want to explain a little bit more what's going on this slide here. This is one of my favorite little slides. If you look at the bottom center, the bottom center graph, that's Node.js number format. I just sort of want to illustrate what's going on here a little bit more. So we start on the top with Node 14, and then we have Node 18, and then we have 2 boxes of Node 20. And you can see how there is sort of a jump between Node 18 and Node 20. The reason for that jump is because Node 20 implemented a new proposal, number format v3, which added support for additional features, and that's reflected in the data-driven tests. So you can see how we turned a number of failing and unsupported tests into passing tests in Node 20, and that's reflected in this dashboard. Another thing you can see is between the second to last row and the final row, there's a few new test differences, failures. That's because we're running Node 20 with ICU 74 data, whereas Node 20 is built with ICU 73 data. So you can see exactly, well, what's the diff if I do upgrade one part of my system to ICU 74, but I'm still using Node 20, what exactly is that diff? And you can see what that diff is using this tool. That's the little red sliver on the bottom center graph. One question that I often received a lot, when I've given presentations here in the past about things like, data slicing at ICU and CLDR and ICU Frex and other things is like, well, what's the risk to me if I switch from what I'm currently using to this new shiny thing, whether it's like, an ECMAScript install in the browser, or if I switch to ICU Frex or whatever it is, like, what's that going to affect? Well, how's that going to impact my application? Now we can actually answer that question with numbers quantitatively, and I think that's a really great outcome of this Unicode conformance testing project. So, just giving a little of my own editorializing there.
Manish had a question. Yes, it should give people confidence in trying out these new methods. One advantage of ICU for X is that it can work on smaller platforms, smaller memory. It economizes with the data that's needed. And if you're a little nervous about ICU for X, you could make sure that ICU for X is running with your type of data by plugging things into this and comparing with others. Manish.
Yeah, so you kind of talked a little bit about the future of this in that you want more people to use it. You want you want more contributions. From a Unicode standpoint of like this being a kind of artifact that Unicode has, what do you hope to see in the future?
What do I hope in the future? Good question. Well, I would hope to expand this to all of the specifications that the ICU libraries have already. All the test specifications should be covered by this. I hope that it is something that people routinely will add when they're developing a new platform. And I would hope that we actually get the red out, as they used to say about Visine and other iDrop products. Make sure that we are indeed being consistent among these things. We should also eventually want to reduce all those gray bars. Am I getting the gist of your question?
More like you from the point of view of things Unicode publishes as artifacts, like Unicode publishes all of these libraries. Are you looking into this becoming one of those things? As in, here's our conformance thing that we also guarantee to maintain. Is that like a future you're hoping for here?
Boy, you're catching me flat-footed, so to speak. I hadn't thought too much about that. I've been so busy trying to get this darn thing to work that I haven't thought as much about that future goal as I'd like. But good question, and that will motivate me.
Let him go first, because I already.
Colin, did you have a question?
Yeah.
Comment?
Do you already have tools or mechanisms for slicing the data into dimensions that you really care about, like a CLI or other ways to configure it?
A CLI?
Command line interface or any other kind of configuration that you can use to just target very specific dimensions of the data, very specific dimensions of the.
I have some things, not a lot. Are you thinking like you'd only want to run a particular set of test types on something?
Yeah, well, specifically, if we were going to upgrade part of our system, there are some dimensions in that we don't care if they break because we're not really focused on it specifically. So how can I limit what is being run? How can I limit and get a really good quantitative analysis of parts that we really care about?
I think I understand. There is one script file Well, there are two files that are important. One is a run configuration, and that run configuration says run node 14 with ICU versions here. Run node 16 with these different ICU versions. Run ICU for X with this particular thing, and with particular test types. So the run configuration says what things you want to run on what data, and then there are specific command lines which literally say Python testdriver.py and the names of the test types that you want to run. You can also limit the amount of testing data in there. So to some extent, maybe not all the dimensions you're thinking about, but these are literally Linux command line scripts that are running these things, feeding information to Python programs, which could pretty easily be changed if you needed to make them more specific.
Thank you, Craig.
But because it's been mostly Googlers playing with this, and it's been mostly me playing with this, actually, I haven't thought of all the dimensions or all the future things quite yet. But yes, take a look at the code. It's all out there. There's no secret sauce.
So, Craig, I understand this is in the space of conformance testing. However, many of us using CLDR or ICU data want to work with some custom version of the data because for our applications or our users, we need to tweak the data in a certain way based on the history of our applications or just what our users are saying to us. So is there a way to work with this and have tailored data? Do we have to duplicate the entire structure and make our own, or is that just not in the scope of
Tailored data is in the tests that you're running? Or?
No, actually,
Yes.
tailoring the CLDR data. We want a date format that's not what ICU recommends for a particular
I don't think
situation.
I think you're asking if I want to run Node version 18, JavaScript, with a particular version of ICU data that might be different. There may be a way of doing that within Node, but I'm testing Node. I'm not testing Node and exactly how it goes in here. The different ICU data versions that I'm testing are the specifications, but not the underlying implementation
Right, it's
of
just
Node.
performance.
So maybe, but I don't exactly know how that would be done. I have to admit one more thing briefly. I grew up in the 1960s and 1970s, and being conformant was not exactly the right thing to do here. So this is a stretch for me to be.
Craig, what changed you?
Anyway, Shane.
Yeah, I was just wondering if you can run it on a particular set of locales. Say you only support 20 locales. Is there something in the config file where you can specify that?
It turns out that most of these tests are set up for particular locales. The test generator could be modified for that, but most of the specifications, for example, the number formatting tests say I want to test this on ESMX, Bengali in Bangladesh, and ZHTW. So the test conformance data may not have the information that you want there. You could build your own conformance data, change that file, and run it through the testing and that, or the test generation, and that would give you what you want. But you got to have the right conformance data to begin with. But it surely wouldn't be hard to do.
Yeah, one thing I'll just add to that is when you, in addition to building your own conformance data, like if you have specific needs, like, you can then run, like, for example, if you have, CLDR patches and you're running, some version of ICU or ICU for X with those patches, you can see the output of those patches. You can run that through the whole tool. And then in terms of, increasing the data in terms of locale coverage, I think that sort of goes to what Manish mentioned a little bit earlier, which is that, we would like to get to the point where, we have, very comprehensive test data in all CLDR locales for all of these features. In order to get this tool running, we've sort of taken some of the test data that we've already have and sort of plugging that in. And the CLDR has also started to build some of its own data-driven test data. There's a new directory in the CLDR repository that contains this. that I think directory is going to continue to grow and, expand its scope over time.
Anne-Marie had a question.
How are you thinking about geopolitical stuff if you're doing conformance tests on language name, for example? Yeah.
That's a good question. Names of countries, names of languages do depend upon the particular locale. The test conformance data could be enhanced. It turns out with language names, we don't have a standard file that's being used. We actually have a set of Google data that we're using for this. So that could be plugged in. I think the language names needs to be enhanced with handling dialect names and alternate names. Right now, I'm not testing for those things, but I don't know if Node or ICU4X handle those variations either. This would be a way of finding out what the behavior is.
Okay, we have time for 2 more questions, and the first is going to be Bob.
Uh-oh. When your boss asks a question, you got to be careful.
Do you test for a failure condition, bad parameters, the locale data is not present, things like that? Do you test to make sure we fail correctly?
I'm testing for failures. A lot of these are, almost all the tests have a try and then an accept or a try and exception state, and then I capture the error that comes back. So if I try to
Do you create failure modes that you know should fail and test that it fails correctly?
no, not at this time, because that's a good point. I haven't generated those because the conformance test doesn't have things that tell me what should fail directly, as far as I know.
There's a few examples of that in likely subtags. I think we were, those are currently showing up in the red box. We do need to figure out exactly.
But they're unsupported, but it doesn't, but the conformance data doesn't say this should fail. The conformance data says this is the result you should expect. But there, as far as I know, there's nothing in the conformance data that says, put this in and boom, it'll blow up, or boom, it won't work.
I think there's also a lot of cases where, like, if a thing is failing, like, it should fall back to some, like, root format, and, like, that should hopefully be performance data.
So that may be a hole in our scheme, that we don't have things that we explicitly expect to go boom.
We have time for the last question.
Can this one run on application level? So this only run on the platform, right? Like this 4 platform there. So we have application, for example, we have a GitHub repository for a specific application. Can I plug this one in and then text my application?
You could anything that you could run on a command line on a Linux box or a Windows environment or a Mac, you should be able to run that. Whether you'd want to put it into the standard GitHub for your particular application is another question. But you could adapt this. You could build a run configuration to run particular tests for your particular personal or your library for your company's product. But the question about whether you want to make that public is up to you. So I think it's feasible. We haven't tried that yet. We have internal libraries at Google have asked exactly that same thing. And the answer is nobody's tried it yet. But thank you for the question. These are all good questions. They make me think about what will keep me busy for the next 6 months. Thank you. Shane, are we done?
Yeah, let's give Craig one more big round of applause. Thank you.
What do I do? Stop recording?